An enemy dismounted infantry force is conducting a linear defense with companies online, platoons online. A complex obstacle belt is forward of the enemy trenches. It consists of a protective minefield on the forward edge of a 4-meter wide and 2-meter deep tank ditch. Approximately 10 meters behind the tank ditch is triple-strand concertina, signifying the start of a 40 to 50-meter deep anti-tank, anti-personnel minefield, buried and bounded at its rear with another row of triple-strand concertina. Continuing 1 to 200 meters deeper into the obstacle, the enemy has buried another 6 to 8 meter protective minefield, bounded on the front and rear by triple-strand concertina that can have a barbed wire apron on the front wire. Total depth of this obstacle is 2 to 300 meters. This is a view of the obstacle as we approach it in a helicopter from friendly positions. Note the difficulty in identifying the enemy positions beyond the obstacle. Trench line, weapons, and firing positions simply blend into the distance. The enemy platoons are defending with 2 squads up and 1 back. Each platoon position consists of a trench line with communications trenches connecting the dismounted infantry squads. The enemy will use RPG-7 and SPG-9 positions on their company and platoon flanks. Prepared armored vehicle positions are 350 to 500 meters behind the infantry trenches. Platoon defenses include 3 AT-3 Sagers or similar anti-tank guided missiles and anti-aircraft weapons used in the ground support role. A tank counterattack force can arrive within 20 to 25 minutes after the enemy identifies the site of our breach effort. From the flank, the enemy position will look like this: a long communications trench for each squad connecting to a series of 2-man fighting positions. In this training film, you will see the breach and assault companies of a task force executing an attack on these prepared enemy positions using both force-on-force and live fire. We have assumed that our task force is one of the lead task forces of a 4-battalion brigade making the division main effort. This brigade will execute 4 simultaneous breaches, 2 by each of the 2 lead task forces. 2 task forces will be held in reserve by the brigade to reinforce success and to destroy counterattacking enemy forces. Corps and division commanders have recognized that they must destroy all enemy artillery that can range the main breach effort. Accordingly, a sophisticated Corps counterfire program has been developed making use of tactical air power and the multiple launch rocket system, MLRS, to destroy identified enemy artillery. The division commander further plans to commit Army attack helicopters to reinforce direct fire suppression of the main breach site or to destroy an enemy counterattack. Now let's look at the task force mission and concept. Task Force 163 attacks 05, 1300 November 90 to penetrate the enemy first echelon defending platoons on Objective Green, secure 2 breach sites, defeat local enemy counterattacks, and support the forward passage of Task Force 152 and other elements of the 1st Brigade. In his MET-T analysis, the commander has carefully considered how to best mass combat power against the enemy, quickly breach the obstacle, exploit enemy weaknesses in assaulting his trench line, and block local counterattacks. He has gained precise information about both the obstacle and the trenches, and he has carefully considered fundamental breach principles. Suppress enemy weapons using direct and indirect fires. Obscure the enemy's ability to observe the attacking force. Secure the force to eliminate interference with the breach. And reduce the obstacle by creating at least 2 lanes for the task force. The commander task organizes as shown. The breach team is a tank-heavy team reinforced with an engineer platoon, a combat engineer vehicle, 2 armored vehicle launch bridges, 4 mine-clearing line charges, and 4 armored combat earth movers. The breach team commander will attach an AVLB and 2 aces with MICLICs to each tank platoon, so that each platoon can breach 1 lane. The infantry platoon will provide suppressive fire with its Bradleys and give the team flexibility in the breach. The assault team is augmented with an engineer platoon, a CEV, and a tank platoon to support its mission. The tanks will provide the most survivable platform for close-in suppression of the enemy in the trenches. The task force operation will be conducted in 4 phases. Phase 1, movement to the obstacle. Phase 2, the breach. Phase 3, the assault. And Phase 4, consolidation and forward passage. In Phase 1, the task force will cross the line of departure in a task force wedge formation along axis blue. The mortars, Vulcans, and engineers minus will travel to the rear of the wedge. The support teams will lead on each flank. The breach and assault teams will be in the center. As they near the obstacle, the two support by fire teams will move online to establish support by fire positions. Thus, 22 tanks and Bradleys of the task force will be online on about a 500-meter front, some 200 meters from the anticipated concealed minefield. The remaining Bradleys will stay behind the tanks initially. They can fire through the gaps between forward vehicles or onto the flanks. This will provide sufficient firepower to dominate the objective area, prevent reinforcement, and suppress the flanks. Phase 2 begins when the breach team arrives approximately 200 meters in front of the obstacle. The breach team will make 2 breaches, one by each tank platoon. In each breach lane, a mine roller tank will move forward to detect the edge of the minefield. The Miklik will fire to clear a 100-meter long lane. The roller tank will then proof the cleared lane to an area just short of the tank ditch and move aside to allow the AVLB to be launched. The AVLBs, after launching their bridges, back up and move to a cleared area. The mine roller tanks resume the march across the bridges, followed by the second aces with Mikliks, continuing the breaching drill. The tank mine plows are committed into the lanes as backups for other systems. The roller tank continues to proof the lane as long as it is operational. If it becomes inoperable, or if the second Miklik fails to fully breach the minefield, the plow tank assumes the lead and continues the breaching operation. The combat power of the breach team is committed to the cleared lanes as soon as possible, with the company team commander positioned well forward. It is imperative that the breach team continues its suppressive fires while in the lanes. As the breach team closes to within 200 meters of the trench line, the company team commander lifts and shifts the indirect fires. This ends Phase 2. Phase 3 begins as the breach team rapidly passes through and around the trench line and establishes its subsequent blocking position. The assault team is committed to the cleared lane immediately on the heels of the breach team. The breach team has moved 500 meters beyond the enemy trenches and are prepared to meet a counterattack. The first assault team will follow them through the breach and assault the enemy trench from the left. Close behind the first assault team, the second assault team, previously supporting by fire, will follow through the breach lane and assault the enemy trench line on the right. This will provide a mech-heavy team to assault and clear each of the entrenched enemy platoons. Once most of the trench lines are secured by the assault team, the task force will begin Phase 4. The second support team will move through the breach site and occupy a blocking position alongside the breaching team, and the task force will prepare to support the follow-on force. Now let's look at the execution of the plan. For the sake of this film, we are executing the plan in daylight and under minimal obscuration. These heavy indirect fires, dual-purpose ICM, HEVT and quick, followed by smoke, impact across the objective, supporting trench lines, and other positions to suppress the enemy and obscure friendly movement. Continuous artillery fire would be maintained throughout Phases 1 and 2 of the operation, a period of time in excess of 30 minutes. These fires would not be shifted until the breach team is within 200 meters of the trench line. Task force mortars move in the formation initially, then halt and prepare to fire on call of the lead team. In Phase 1, the breach and assault teams are approaching the obstacle at 20 kilometers per hour. Commander is leading with tanks, and until receiving fire, the vehicle commanders are up and scanning for targets. The breach team initially moves in a wedge formation, but then transitions into a line formation with its vehicles 25 meters apart, to better achieve mass at the breach site and to avoid masking its own fires. Leading with tanks is essential, not only for survivability and suppression, but also to be able to defeat any enemy reinforcement. We can expect that reinforcement soon after the enemy detects the location of our main effort. Despite the best division and corps efforts, the breach team has to expect to receive both direct and indirect fires, and thus be prepared to execute the entire operation buttoned up if need be. When 1,500 meters from the obstacle, the artillery fires illumination rounds set the ground burst on the objective to assist in both fire control and navigation. Crews with thermal sights can use the illumination round as a reference point to orient fires and direction of travel. As the task force comes up online in support by fire positions to suppress the enemy, we begin Phase 2, the breach itself. The roller tanks and the two breach platoons take the lead to identify the minefield's edge. They should begin about 200 meters from the forward edge of the suspected minefield. We lead with roller tanks instead of plows because rollers are faster, can survive more mine hits than plows, are more maneuverable, and provide positive minefield identification by detonating a mine. The roller tanks will lead in proofing and marking separate lanes and travel 50 to 100 meters apart. An armored combat earth mover or a combat engineer vehicle will follow each roller tank towing an M58A4 Miklik. Enemy anti-tank fires, the number of vehicles available to the task force, and their follow-on mission will determine the selection of either the CEV or ACE. Initially, the preferred vehicle is the ACE because of its ability to plow mines buried 12 inches deep with its blade. Because of the greater enemy fires as we penetrate deeper into the obstacle, the CEV will be a better choice for the second Miklik. At this time, the engineers establish fire recognition signals using large painted panels approximately 200 meters from the breach lane's entrance, and HEMS poles with VS-17 panels at the breach site to mark the entrance for the assault team and the remainder of the task force. Again, this entire operation should be obscured from enemy observation if possible. Mine roller tanks move forward at 12 kilometers per hour. They will move forward until detecting the forward edge of the minefield by exploding a mine. The lifespan of a roller is 2 hits by mines. The roller tank's driver will also carry and use the command-activated Cleared Lane Marking System, or CLAMS, when he enters the lane. The task force must suppress the enemy while this element moves forward. When detecting for mines, the roller tank must keep its gun tube at least 30 degrees away from the vehicle's front so that a mine detonation will not damage the gun tube. When breaching, the main weapon of the roller tank is its machine guns. When the roller tank hits the first mine, he immediately fires his onboard red phosphorus grenades to cover himself. He then backs up 5 vehicle lengths or approximately 50 meters to establish the correct standoff for the following Miklik. The ACE, towing a Miklik behind, moves up to within 10 meters of the roller tank, stops, and prepares to fire. The ACE driver fires the Miklik rocket over the roller tank on the engineer platoon leader's order. Setup and firing takes between 2 to 4 minutes. The roller tank's driver and TC verify that the Miklik charge has landed in front of their vehicle before the ACE driver command detonates the charge. A 62-meter line is attached to the charge's end that offsets the charge from the Miklik for firing. The charge will create a lane 100 meters by 14 meters against older-type mines through explosive overpressure. In this exercise, we have assumed the Miklik to be effective. However, we know that some modern mines are resistant to destruction by the Miklik. For this reason, we will have to proof the lane that the Miklik has cleared with either the plow or roller. After firing its Miklik, the ACE or CEV plows to the inside of the lane to get out of the way. It may later assume a follow-on or contingency task. In this situation, the Miklik lane spans the anti-tank ditch. Thus, the roller tank proofs to the ditch's edge, backs straight back approximately 25 meters, and then moves off to the inside to make way for the AVLB. The AVLB, which has been waiting just outside the minefield, moves forward in the lane to the ditch's edge and employs its bridge to cross the gap. The crew will try to set the bridge equally on the proofed friendly lane and the far side, because even if it detonates a mine on the unproofed side, it can still support a tank crossing. Here we see the AVLB from the enemy's perspective. While employing the bridge, the AVLB operator will launch his red phosphorus grenades to provide close-in concealing smoke. An AVLB bridge will support a roller tank, but it is a risk crossing because of the weight classification. After deploying the bridge, the carrier will back up in the lane to give the roller tank room to get back on the lane and cross the bridge. It will then move into the tank's place on the ditch's edge. The roller tank and a second Miklik that has followed the AVLB forward now cross the AVLB. The dog bone on the roller tank must be modified with the strap so the tank's driver can pull the dog bone up while crossing the bridge to stop its chain from damaging the bridge's hydraulic lines. If the AVLB breaks or is damaged by enemy fire, the ACE has the capability to reduce the ditch for the roller tank to cross. Though slower, it too can accomplish the mission. The roller tank proofs the first Miklik's lane until detonating a mine. He then pops red phosphorus grenades as he backs up approximately 50 meters to achieve the required standoff for Miklik firing, as well as because he is a major direct fire target as he nears the enemy positions. The second Miklik closes to within 10 meters and prepares to fire. The second Miklik will extend the lane to a total of 160 to 180 meters for the breach team. Because of its nearness to the enemy and vulnerability to handheld anti-tank weapons, and the plow blades of both the CEV and ACE give them some capability to breach by skimming mines if needed. However, this is only recommended as a contingency method of breaching. After the second Miklik fires and detonates, the roller tank, if it is still operational, continues to proof until it hits another mine or reaches the obstacle's far side. If the roller hits a mine or becomes disabled, the mine plow must begin plowing to continue the breach through the obstacle. The mine plow cannot turn while plowing. The ACE or CEV and the roller tank will immediately back up and begin following the mine plow. The roller tank reorients its main gun to the front to engage and suppress the enemy while the plow finishes the breach lane. The tank plow appears to be the most reliable of the breaching devices, especially against modern mines, although it is also the slowest, least maneuverable, and most easily destroyed. Each plow can probably sustain only a single explosion. Its advantage is its heavy armor, offensive armament, and the ability to rapidly move into the breach and survive. The plow has settings for 8, 10, and 12 inches, but will be set on the depth determined during the IPB process for the expected characteristics of the enemy minefield. As the plow approaches the obstacle's far side, the support force shifts direct and indirect fires to expected enemy counterattack routes. The roller tank and the plow tank establish local security on the far side of the breach. An engineer vehicle follows his first tank section through and marks the breach lane using some highly visible marking system, like tippy toms, to guide the remainder of the breach team and the assault team through the lane. We have now begun Phase 3 of the task force operation. Using the clams markers and the engineer markings such as highway cones as their guides, the other tanks of the breaching team rush through the obstacle and continue beyond the trench systems. We want them to halt about 500 meters past the enemy trench line in order to isolate the objective and guard against a possible enemy armored counterattack force. The remainder of the breaching company joins the tanks in setting up this blocking position to isolate the objective. Meanwhile, the assault team has followed immediately through the marked breach lane right on the tail of the last vehicle in the breach team. The tank platoon leads the assault team. This platoon sets up firing positions immediately outside the breach lane and begins to engage the forward trench line. Then, the Bradley fighting vehicles move up to within 20 meters of the end of the trench line. They orient their turrets so their coax and 25mm guns can depress and fire directly down the long line of the trench for close, immediate suppression. These guns will pin the enemy down while the infantry dismounts and then provide close support to the dismounted assault teams while they're in the trenches. The squad rapidly dismount using the standardized drill. The key to entry into the trench line is heavy suppressive fire that allows dismounted maneuver to within hand grenade range of the entry point. The converging fires from the flank tank and the Bradley fighting vehicle in the trench's end both mark the entry point and give the dismounts suppressive protection. That gives them time to employ fire and movement in the assault of the trench. A smoke grenade signals the vehicles to shift their fire so the dismounts will be able to enter the trench. Entering the trench is the most critical point in the assault. It is done with intense suppression, grenades, and bayonet assault. The entire trench fight is a close quarters battle. Success depends on gaining and maintaining fire superiority and then destroying pockets of resistance using hand grenades, automatic weapons, and M203 grenade launchers. The infantry are organized into 3-man assault teams. This gives the team flexibility in terms of having someone to fire, someone to support, and an immediate replacement. Notice the soldiers nearing the trench cook their grenades before throwing them into their selected entry point. This denies the enemy the chance of retrieving and returning their grenades. The assault teams use grenades before entering any enemy position or any new section of trench. Notice that they're wearing body armor and rucksacks loaded with additional ammunition and hand grenades. Soil conditions in trench construction determine hand grenade standoff. Loose soil increases the risk of collapsing the trench. The first team to enter is responsible for securing the entry point. They will stay and hold it for follow-on teams. They will use saw fire to maintain continuous suppression down in the trench line. Notice the obscuration caused by sand and dust when firing in the trenches. The confusion and limited visibility caused by this obscuration necessitates solid, well-rehearsed drills. These drills not only speed the assault, they also reduce casualties. This unit trained for 2 weeks and progressed from losing a full platoon in a force-on-force clearing operation to only losing a single man. Observation and fire must be continuously maintained down the length of the trench. The 3-man assault team must throw grenades at all bends of the trench to forestall ambush and round corners firing continuously. Firing down the length of the trench using squad automatic weapons requires 2 weapons forward and a continuing resupply of ammunition. The lead man in the trench never takes his eyes off the trench. Bayonets are fixed for the close combat and fighting positions and when ammunition unexpectedly fails. Trench fighting, although fought by 3 men at a time, is a manpower-intensive operation. The 3-man teams are drilled to pass around each other if necessary. The direction of clearing is marked using poles marked with engineer tape in front of the cleared positions. Speed, violence, and command and control are key to success. The fourth man carries a signal flag attached to a pole or antenna on his back that the supporting vehicles can identify. Supporting vehicle fires are always placed 25 meters forward of that flag. Two-man sapper teams from the engineer platoon will augment the infantry assault teams. Sappers will carry additional demolitions like satchel charges and handheld charges to destroy obstacles that the dismounts cannot. Bunkers not destroyed by tanks for the CEV also become viable targets for the sapper teams. We see here a sapper in a cleared portion of the trench throwing a satchel charge to destroy a squad bunker. Sappers will also use VS-17 panels to mark the cleared bunkers so that direct fire assets are not wasted. They also make extensive use of the M203 smoke grenade, as do the infantry assault teams, to mark targets for supporting fires. Once the trench is cleared, the assault team commander will signal to the task force commander, consolidate, and reorganize. He then joins in the preparations to defeat the counterattack. At task force level, we are also assaulting and clearing the enemy platoon in the right-hand trenches. As these trenches are cleared, the final team in the task force passes through the breach to reinforce the blocking position some 500 meters beyond the trenches, and the task force prepares to pass forward a trailing task force from the brigade.
Let me offer a few thoughts in conclusion here. Obviously, this is a difficult operation, complicated. 3 weeks in the field with 2 OPFOR companies to produce this thing. And we had a lot of help from the experts, the threat community, the engineer, armor, and infantry schools. The best we could do in the breach phase, from here to here, was about 20 minutes. It involves over 20 separate actions by 4 pieces of breaching equipment in each platoon lane. And frankly, if we'd gone against modern mines, it would have been even more difficult in those lanes. So this is a tough operation. Now, in our film, we're not trying to suggest that such operations should be standardized. Quite the contrary. Any operation like this must be dominated by the specific MET-T conditions. It cannot be standardized, certainly not at task force level, and not even in these breach lanes. Still, we can draw some generalizations from this effort. An operation like this is going to be successful if we've got good intelligence, solid planning, and sound rehearsals. The intelligence has got to be specific, right down to the nitty-gritty details. We can have no surprises in this operation. So we want to know especially the sequence of these obstacles and even the types of mines, how the trenches are laid out, what they're composed of, how the fighting positions are laid off the trenches, and so forth. The planning is a tough problem because it requires command involvement from the outset. We've got to start with the planning for the breach and the assault, and then work backwards toward the LD and the artillery prep from that position. Once we do this, we'll find that the breaching sequence here is one of the critical elements that has to be planned in detail, even at the top. We also need to limit the scope of the task force responsibilities. In this operation, the entire task force effort is directed at these 2 platoons, an area about 500 meters wide, and we don't expect to go with the task force more than 700 meters deep. That's a limited scope operation for the task force. Rehearsals are very important in this operation. We've got to have rehearsals at every echelon of command. Rehearsals are more than the standard NTC rock drill in this case. Really what we need to do is construct and practice on an actual obstacle system and trench system, just as we did in this training film. This practice gives us the opportunity to truly understand the operation at all echelons. It trains our soldiers in their individual actions and in the understanding of how the individual actions fit together to make the operation. And it gives us the capability of adapting the operation in the event of things going wrong, which undoubtedly things will in any operation as complicated as this one. Now, there are 2 very tough issues that we need to make calls on and reaffirm those calls as we go through the planning and preparation for the operation. The first of these issues is the problem of command and control versus obscuration of the breach site. Command and control is going to be very important in this operation. We elected to go with maximum obscuration of the breach and of the from the enemy's position, even if it cost us in the area of command and control. We did this because we thought we could compensate by drills, rehearsals, limited visual signals, and FM in the command and control of the breach. But we knew we couldn't skimp on protection of these vehicles as they go through the breach lanes. The loss of even a few of these breaching vehicles can compromise the task force operation, and so every effort has to be made to protect them. The second tough call involves massing the task force formation. Surely when we come in this tight, the whole task force on a 500-meter front, right up against 200 meters from the obstacle, we're increasing our vulnerability to enemy artillery fire. But frankly, we bucked this problem up to the higher level commanders. This is the problem of the counterfire program. It's got to keep the artillery off the breach force. As far as we're concerned, when we're in here tight, we've got the mass we need to dominate the enemy objective by fire, gaining 4 or 5 to 1 direct fire superiority over the enemy, even if he brings in some reinforcements. We also have the opportunity to suppress these flank objectives here if something happens to the obscuration. So from our perspective, massing combat forces is a must in this operation. Finally, let me say a few words about the equipment. Frankly, we were impressed with the equipment. This is a big step forward for our Army in our offensive capabilities. But there are some cautions we need to note, and we did see some areas where we could make some improvements. Let's look at the equipment now in detail.
The M9 Ace with Miklik was reliable and very effective. We found it could skim mines down to 12 inches if it had to. But in this operation, we're asking a lot of a one-man crew, buttoned up, under fire, and towing a Miklik. And by the way, he can't back up once he's in the breach lane. The Miklik itself was no problem for our young ace operator to learn to use. We employed our Mikliks early in the breach because they advanced us rapidly, and also because they would become increasingly vulnerable as we moved closer to the enemy. In our tests, the Miklik made quite a furrow. It was effective in detonating the older style mines and fuses out to its planning width of 14 meters. However, we also discovered it will not detonate some of the modern mines, even if it lands within a foot of them. We could improve our breach effort by mounting the Miklik on a prime mover, preferably one which can defend itself. We believe it would be possible to fabricate a mount for 2 Mikliks side by side off the back deck of the M1 tank. The tank-mounted roller was surprisingly agile and easy to work with. It moved well in formation and should be effective against the older types of mines. However, the roller only proofs the track's widths, and despite the dog bone hanging down the center, there may be mines remaining undetected in the lane. Finally, the tank plow. The M1 had more than adequate power to drive the plow, and since it physically moves the mines, it proves a valuable addition to the breach set, especially with modern mines. Unfortunately, it also clears primarily in front of the tracks, and some mines, even surface laid, may slip through the dog bone in the center. We should attempt to extend the plow across the front of the tank, and we should add some wire cutters to both the plow and the roller. Incidentally, we discovered we can plow only in a straight line and only on level ground. Efforts to turn the tank while plowing, or driving over even small folds in the ground, produce results like this, with one side of the plow partially lifted.
One thing that's clear is that no single piece of breaching equipment is good enough all by itself to do the job. That's especially the case against the more modern mines. Any enhancements, by the way, we could get to deal with the modern fusing and mine techniques would be most useful. But the point is that these pieces of breaching equipment must be used together. They are complementary. And frankly, that fact is what makes this such a complicated operation. And that suggests to us that anything we can do to consolidate the functioning of different pieces of apparatus onto a single vehicle is going to simplify the operation. Nevertheless, this is a big step forward for the Army. The current capability works. With intelligence, planning, rehearsals, good training, we can breach now and assault successfully. Thank you.